All right, this is going to be a good video. It's on Euler's formula, one of the most remarkable formulas you'll see in this whole course. And it begins with the series for e to the x. So we know this is 1 plus x to the first over 1 factorial plus x squared over 2 factorial, and so on. X to the third over 3 factorial, fourth over 4 factorial, fifth over 5 factorial, and so on. So Euler's formula has to do with complex numbers. So what would happen if I plugged in e to the I times t for x? So I is the complex number, the square root of -1, so I squared is -1. So I'm going to put that in wherever I see an x, it. So I get 1 plus it to the first power over 1 factorial plus it squared over 2 factorial plus it cubed over 3 factorial plus it to the fourth over 4 factorial plus it to the fifth over 5 factorial, and so on. So I'm going to simplify this a little bit. So I'm going to start with 1. And then I'm going to write every term that has the complex number I in it in red. So this term can really be written as I times t to the first over 1 factorial. The next term really doesn't have an I in it. I mean, it looks like it does, but when you square I squared, you get -1. So this is really just negative t squared over 2 factorial. The next term does have an I in it. I to the third power is -I. So that'll be in red. So I'll do -I t to the third over 3 factorial. The next has no I to the fourth power is 1. So that's just plus t to the fourth over 4 factorial. I to the fifth power is I again. So I'm going to write plus in red I t to the fifth over 5 factorial. And then you can keep doing this. The next term I think would be minus t to the 6 over 6 factorial. And you can keep writing things down. Well, look at what happens. Look at what happens. In the pencil color, I have no I powers. I have 1 minus t squared over 2 factorial plus t to the fourth over 4 factorial minus t to the 6 over 6 factorial. I actually recognize that. That's actually the series for cosine t. And then in red, I have an I. And then I have t to the first over 1 factorial minus t cubed over 3 factorial plus t to the odd powers with alternating plus or minus signs. We know that's the series expansion for sine t. So we get the amazing result that e to the it power is cosine t plus I sine t. So we find e to the it power is cosine t plus I sine t. An amazing result known as Euler's formula. And this is more than just a curiosity. This is actually a formula that's used extensively as you go on in mathematics. So as an example, you could plug in certain values for t. You could plug in pi, for instance. So pi is a number. I could plug that in for t. Then e to the I pi power is cosine pi plus I sine pi. Now, sine of pi is 0. Cosine of pi is -1. So we get -1. Some people like to write this. Alternatively, they add 1 to both sides and they write it as e to the I pi plus 1 equals 0. And this formula is well known. It's an astounding formula in mathematics because the most important numbers in all of mathematics are definitely 0, 1, e, pi, and I. These are just 1, 2, 3, 4, 5. The 5, probably top 5 mathematical constants that you could even think of. And they're all related by this very simple equation. So that's Euler's formula, a really, really great result.